In this lesson, we introduce basic building blocks of product cipher for symmetric key algorithm and the old data encryption standard. We call it DES. Here we show the basic building blocks of P box and S box corresponding to the transposition cipher and substitution cipher in simple hardware representation. Here we show an 8-bit P box or permutation box. It takes a input, either 0 or 1 signal can be sent into those ports, and it can be sent out and direct to different output ports. It basically shuffles the 0 and 1 in different positions. The shuffling is decided by the 9 patterns shown inside of the P box here. They connect the ports. For example, here 1, 0, 0, 1, 0, 0, 0, 1 will come out through the P box as 1, 0, 1, 1, 0, 0, 0, 0. Note that the number of 1 stays the same as the number of 0. We have 3, 1 here. The lower diagram is a 3-bit substitution box called S box. It composed of a decoder, 3-bit to A output decoder, followed by a P box, followed by A to 3 encoder. Here with 101 bit pattern coming into the 3 port, the decoder will select or activate the 5th output port. Here we use 0 index. The 6th line, we call it 5th port. The top output port is a 0th port. The 5th line signal will be coming out, and then it will drive the P box, and the resulting of that is 7th output port will be triggered, and that trigger will send a signal to the last input port of the encoder, and the encoder will produce 1, 1, 1, equivalent of 7 decimal output pattern. In summary, the S box can substitute the incoming 101 bit pattern as 111 output pattern in a very fast manner with hardware implementation. We can also simulate all these operations using the software. Also, we can verify the bit pattern with the equivalent of 0, 1, 2, 3, 4, 5, 6 decimal coming in. Each of them will produce the value of equivalent pattern, bit pattern of 2, 4, 5, 0, 6, 7, 1, 3 decimal value coming out. A production cipher combines 2 or more transformations to make it more secure and resist to cryptanalysis. Figure C on the right-hand side here is a product cipher utilized 4 P box. In between is 12 S box to construct a 12-bit cipher. Note that each of the P1 and P4 P box and P box inside each of those 12 S box could have different permutation pattern inside. You can envision that we can easily construct by stack up all these 12-bit pattern into a 16-bit product cipher with the same design. DES has a block size of 64 bits. Here we show the basic design of DES. DES stands for Data Encryption Standard. It is a symmetric key algorithm developed by IBM early 1970. National Bureau of Standards, NBS, after consulted with NSA, adopted it as an official Federal Information Processing Standard. We typically call it FIPS, for United States in 1977. Due to the involvement of NSA, it often nourished the suspicion that there is a backdoor built in DES. It has a block size of 64 bits. Basic version has a 56-bit key. It goes through 16 iterations as shown here on the left-hand side, with the initial transposition and later output inverse transposition. In each iteration shown on the right side here, the right 32-bit is sent directly to form the left output 32-bit. The same right 32-bit and the key are then fed into Xbox through some substitutions. The output is then to a big O with the left-hand side 32-bit to form the right side output 32-bit. DES is considered to be insecure now because it was broken by organizations in a distributed decryption effort on internet. It is organized by Distributed.net and EFF early January 1999, and they was broken in just 22 hours, 15 minutes. And since then, NIST has withdrawn it as a standard. To extend the life of DES and the related hardware and software, triple DES was proposed and developed. The same DES encryption and decryption blocks are concatenated as shown here to extend the key length and at the same time make it compatible with all DES processing if the user chooses to do so. The Cybertek is encrypt plaintext with the DES encryption function and the key number 1. And then the result is it decrypts with key number 2, finally encrypt with the key number 3. It uses the same 64-bit block size and has 2 options. The first option is using 3 keys, equivalent to 168-bit key. The second option using K1, K2, and repeat the same K1 as the K3 key, and therefore it has 112-bit key. It has limited usage life based on the analysis right now. Most of people already move to use a new AES standard already. Many new operating systems nowadays already stop using and accept the 3DES and DES as a cyber threat in accepting the SSL secure connection.